All right, so let's take a look at the second day of rational functions. Today's April Fool's Day, so be careful. Today's going to be section 9.1. We're going to be graphing rational functions. Call this day 2. All right, so let's take a look at different kind of problems today. Remember, all rational functions have 4 steps. If you need to remember what they are, just scroll back in the notes. My OneNote's still active, or you could just open up the video from yesterday. I'm going to get right into the new lesson. So the first problem I wanted to go over with you looked like this. F of x is equal to x to the second plus 4x minus 5 over x plus 5. And going through our steps, first step is we always factor. Well, this problem's a little bit different than yesterday because this does factor. If we factor it, it turns into x plus 5 times x minus 1 divided by x plus 5. These actually cancel out. So all that we're left with is the function f of x is equal to x minus 1. We don't have to go on to step 2. This is what we're actually graphing. That's a simplified version of the original expression. It's kind of like if I asked you, can you give me 12 over 2 M&Ms? I like M&Ms. I'm always thinking about chocolate. You wouldn't give me 12 and then divide it by 2 and take 6 for yourself, and that's not how it would work. You wouldn't even think about this once you simplified it to be 6. So once you simplify and factor, this is now obsolete. Obsolete means it's old, it doesn't matter anymore. This is going to be what we're graphing. There's one catch though. In the notes we said that when you factor, if you cancel factors, you get a whole when they equal 0. That's what we're going to be looking at today. So let me show you what that looks like in this lesson. We canceled out x plus 5. We make it equal to 0, and there's going to be a whole whenever x is equal to negative 5. So as far as what this first graph would look like, let me show you. Start at negative 1. This is a linear function. It's in slope-intercept form. We're going to go up 1 over 1. Try to draw a straight line here. That's what the graph would look like. Now, if you go to my website and click on the free Conic graphing calculator, you could type that in. Just type y is equal to parentheses x squared plus 4x minus 5 and divide it by parentheses x plus 5. And even though it looks super complicated, you would just get a straight line like that, a diagonal line. The only difference is we have to put a whole on the graph when x is negative 5. So this is negative 1, negative 2, negative 3, negative 4, negative 5. I'm going to go down to the graph. And I'm going to put a whole right there at negative 5. The reason why we do that is this line represents all possible xy solutions that would satisfy the original problem. Problem is, if you don't put that whole there, you can't use negative 5 for x because that would make the denominator 0. So the way that we have to show that in our revised graph is we just put a circle there, which means a whole, which means you could use any x and y value along this line, but you're not allowed to have any point when x is equal to negative 5. That's what the whole means. Let's take a look at another problem. What if I asked you to graph f of x is equal to x plus 3 over x squared minus x minus 12. First step that we have to do is factor. And we'd say f of x is equal to x plus 3 over, this would be x plus 3 times x minus 4. So you can see that these cancel, leaving you with just 1 on top over x minus 4. Now you don't get too happy that they canceled. We still have to remember that there's a hole on the graph when x plus 3 equals 0 or x equals negative 3. So we'll remember to do that a little bit later. So this is obsolete. We're working off of this graph now. Because there is x in the denominator, we have to go to step number 2, which was to find the vertical asymptote. We set the denominator equal to 0 and solve it. So there's a vertical asymptote when x is 4. Okay, so now let's go to step number 3, horizontal asymptote. Remember, we're looking at our simplified version. The degree on top is 0, the degree on the bottom is 1. Whenever the top is smaller, this just means y is equal to 0 is our horizontal asymptote. So I'm going to draw that right here. That's the line y equals 0. And then my last step to figure out the branches, I'm going to pick values to the left and right of each vertical asymptote. Vertical asymptote is 4, so I'm going to plug in 5. I'm going to plug in 3, and I'll plug them into my simplified version. If we were to plug 3 in, we'd get 1 over negative 1, which means the point 3, negative 1 is on this new graph. And we're going to approach the asymptotes. If we plug in 5, 1 over 1 gives us 5, 1 on the graph. Get close to the asymptotes. That's almost what the graph looks like. We just have to remember we had a hole when x was negative 3. So we go to the graph when x is negative 3 and go to the graph itself and put a little hole there. That would give us the correct answer. A couple more problems and then we'll be done today. What if we had a problem where y was equal to negative 3 over x squared minus 2x minus 3? Step number 1 is we factor, and remember if anything cancels, we're going to get a hole on the graph. So y would equal negative 3 over x minus 3 times x plus 1. Even though we factored, nothing cancels. Oh well. There's no hole, we go to the next step, vertical asymptote. Now the rules in math are always the same. The way you get the vertical asymptote is you make your denominator equal to 0. So the denominator was x squared minus 2x minus 3. If we make it equal to 0 and solve it, we get a vertical asymptote at 3 and a vertical asymptote at negative 1. So we get 2 vertical asymptotes. It's not a big deal. It's not better or worse. We're going to follow all the same directions we've been talking about all along. There's a vertical asymptote at 3. And negative 1. All right, let's go to step 4, the horizontal asymptote. Now the degree of the numerator and the degree of the denominator. So the degree on top, there's no x, so the degree would be 0. The denominator's degree would be 2. In this case, y would equal 0. That's what that would look like. And label it. So now we just have to figure out where the branches go. Now the way we always get the branches is we test values to the left and right of each vertical asymptote. So I'm going to test -2, and I'm going to test 0 for this one. For this, I'm going to test 2, and I'm going to test 4. I'm going to be plugging in these values into the original. Now I had taught you how to store numbers in your calculator before. So if we store -2 on my calculator, I'm going to type it in like this. I'm going to type -3 divided by parentheses a squared minus 2a minus 3. And I'm going to store -2 in for a and see what it gives me. Now you don't have to store, but that's a faster way that I usually do. So I'll type in -2, store for a, and I'm going to type in -3 divided by mem variable a squared minus 2a minus 3. My calculator is telling me y would be -0.6. So the point -2, -0.6 is on the graph. -2, -0.6 is over here. I'll draw my branches in a little bit. I'm going to store 0 for a, and I'm going to type in that equation. And with 0 stored, I get 1. 0, 1 is right here. With 2 stored, I get 1. So the point 2, 1's on the graph. And with 4 stored, I get -0.6. We draw all our graphs the same way. We get approach the asymptotes. Approach this asymptote, this one, and this one. So you can see that looks like a parabola. Approach this asymptote and approach this asymptote. That's what that graph looks like. So even though there's two asymptotes, two vertical asymptotes, it's not a big deal. All the same rules apply. One thing that I will mention, and we'll finish with one more example, is if there's two vertical asymptotes, there's 4 possibilities between them. I'll draw it like this. Okay. If you have 2 points, like in our last example, that are above the horizontal, in the middle they could look like a parabola. If the 2 points are below, look like a parabola. But in the middle, sometimes what can happen is you can get a point above and a point below in the middle section. In this case, you would connect them to look like a cubic graph. Remember, a cubic is a squiggle. So if you had one above and below, they would connect to look like a cubic going that direction. So in the middle, that's the only time you wind up possibly crossing over an asymptote. So one more example, and then I'll give you your homework. Fourth example says graph y is equal to x over x squared minus 4. First step is we factor. Remember, we're looking for cancellations to get a whole. Nothing cancels, so we move on to step 2. Step 2, we get the vertical asymptote by making the denominator equal to 0 and solving. Now we could factor this, or even just bring the 4 over, take the square root. You guys know absolute value. So we'd get 2 vertical asymptotes here, positive 2 and negative 2. All right, so let's keep going. Let's go to step number 3, the horizontal asymptote. The top degree is 1, the bottom degree is 2. So we have another y equals 0 horizontal asymptote. And then for our fourth step, we want to figure out where the branches go. We're going to be plugging in values to the left and right of each of these vertical asymptotes. So I'm going to plug in -3 and -1 for the one on the left, and I'll plug in 1 and 3 for the one on the right. Talked about in the last example how to store. On my calculator, I'm going to store -3 for A, or for X if you're using a different calculator. I'm sure you guys can figure it out. And I'm going to type in A divided by parentheses A squared minus 4 into my calculator to figure out what the Y values would be. Alright, so let's do this. -3 store for A. And on my calculator, I'm going to type in A divided by A squared minus 4. And with -3 stored, we get -0.6, which means -3, -0.6 is on the graph. It doesn't have to be exact. I know it's definitely below the horizontal asymptote, which is the most important thing. If we store -1, I'm getting 1/3. So the point -1, 1/3 is on the graph, which is above the horizontal. If we store 1, I'm getting -1/3. So the point 1, -1/3 is on the graph. It's below the horizontal. And then if we store in 3, we get 0.6. So the point 3, 0.6 is on the graph. Remember, on the ends, we just approach the asymptotes. And in the middle, if we have one above and one below, they cross over looking like a cubic function. For homework tonight, what I would like you to please do is on page 554, I would like you to do numbers 13 to 33 odd. And I would also like you to do on practice 9-1, please do numbers 1 and 2. Thank you very much. Have a nice day.